What is this? It's a Sony MSU-700 master setup unit. What does that mean? What does it do? Well, it's for going into your control room or your OB van truck. It's TV studio stuff. Connects to presumably up to 12 cameras, studio cameras or ENG type cameras that are cabled back to remote control units. Allows you to adjust all of the configurations of the cameras from this unit in the control room to ensure the picture and settings of them are all consistent, so you can make everything look good, so you're not seeing different colors or brightness when switching between different cameras. Yeah, so this was, I don't know, it's another thing that's just been sitting around here for a really long time. I have had a go at this before because it didn't turn on. We'll get into that. It's got a memory card slot of some description. Guessing that's some sort of PCMCIA type deal. A lot of buttons, a screen with what looks like an XY matrix type of touch on it. There's a grid of sort of 10mm by 10mm squares on there. So it's fairly coarse type of resistive touchscreen. Various encoder knobs, master black, iris, call. That way the currently selected camera indicated there by a number, which you'd select by this, and with expand maybe it can go further, maybe it goes up to 24. Tele multi panel active. Oh, that must be when you click it, I guess. Then a whole bunch of stuff that I don't really know what most of it means, but it's basically all of the functions of a camera of this unit's age or series. Everything that you can do on the camera, like changing it between different previews, the different input signals to the camera, bars, and then setting detail, knee, level, gamma, chroma, matrix, the white balances and iris type stuff, shutters, gamma, master gain, ND filters, CC, as I guess has color corrections in it, the different things that can flip in front of the image path, waveform monitor, picture monitor, so you can see the signal coming back from the camera, iris master black active, meaning you can override it and change it, and modes. Alright, so how does this hook up to the system? It's got a remote CCU CNU, and as far as I know that means you can connect to just one camera control unit or a camera network unit, I think, CNU, which then will split it out into a whole bunch of connectors to go to all of your camera control units. So if you're using a cable kind of like this, but sadly not this one, I don't have the cable that goes on there. You never get the cables with this stuff. That's always just been ripped out of an infrastructure and just thrown in the trash or to a scrap dealer, isn't it? And so you get all the units and none of the very special hard to find cables. Sad. So the other end then will be presumably not this, but a newer model of camera control unit. Did a teardown on these some time back, but you see on the back there's a remote connector, and this one does almost fit this connector, but not quite. It seems to be like a slightly more pins version. Yeah, it's got 3 in the center, whereas that has 2. But otherwise it would have fitted on there. Anyway, it's still not the cable that goes with this. This is some other cable. I think it's some kind of camera extension thing for one of those little cameras with a really tiny head and then a separate unit with all the guts of the camera in it. Anyway, we've done camera control units in a previous video, so if you want to know about those, you can look at it. Because we took apart one of those model and a different one. Is that a D37 I/O port? I guess that's extra I/O. So I have taken this thing apart already because I tried plugging it in before nothing happened. It's got this quite nice power switch where it's difficult to accidentally switch it off. Nice recess to turn on, and even more recess to turn off. There's a fuse under that, apparently. And yeah, somewhat shrouded with ability to have a retaining clip, IEC AC power input. Yeah, fuse. Maybe we should check that, since this thing was fully dead and I didn't check this fuse. Oh, it's got sand in it, so actually you're going to have to measure it. Proper high rupturing type of fuse. No, the fuse is fine. Let's just check that fuse from last video where we took apart those HP things. No, that's fine. I noticed that was still sitting there, so there you go. Wasn't the fuse on that thing. Right, so let's take it apart. I've already undone all the screws, I just never got around to putting them back, so this thing will just come apart. Maybe it's a pretty quick teardown today. Possibly a good thing, because I'm very much running out of time. Look at that. Very high density ribbon cable. It says CPU. CPU CN. So that's for the expansion connector. But there's the power supply. Weirdly, the AC side comes over here and the DC side over here, so it's like rotated. Oh, that's because it was connected, screwed onto this back plate, and that was happened to be on that side, so they didn't have a choice. Look how they had to insulate the cables, the wires, with this sleeving. But the power goes into that board that's got the D connector and the remote connectors on it. So it must come over this high density ribbon cable. It's like it's a 100-way version of what we used to have for IDE connectors. Pretty interesting. Must be some filtering in the IEC inlet. Invades the PCB area a bit. Quite a bit of stuff in here. Hitachi chips, some Sony chips, Oki chips, bunch of those. Hitachi, presumably microcontroller, RAMs and ROMs. More ROMs, presumably a whole bunch of tiny little dip switches. An option board. Don't know, it goes somewhere. A reset button. The buzzer on off switch there. Ah, look at that. The connection to the touch panel is there. You can also see the ribbon that comes off the presumably LCD, though maybe I was wondering if this is an EL type display, like electroluminescent. Let's see if we can get this thing going to find out that, yeah, that colored ribbon, that colored cable there is the display connection. Interesting, there's discrete wires. Oh, and it says on the little bit of text under there covered by all that stuff, it says EL display, so I guess it is an EL display. Hopefully that will work and we can turn it on. And then that ribbon cable there, it says paint. Paint. I wonder if that means it goes to some knobs or something. Does it really say that, or does it say panel? No, it says paint. That one there says 2 switchboard, master black iris, so that comes from the encoders directly. And yeah, look, they're nice fancy ones. They feel quite good to turn. Switchboard there, 2 switchboard A, 2 switchboard B, and then those ones there. I think they both go, well, there's actually 3, there's another one over here. They go to the card slot thing. Oh, look, it's not an IDE, like IDC normal, it is actually a full high density ribbon cable connector that brings out all the cores, not like on those IDE ones where it was an 80 core ribbon, 40 pin plug, and then it used every second one as a ground to achieve the higher frequencies, higher speed, higher performance, higher frequencies. Ah, and there's something very useful here. There are test points for the supply voltages. And that's very important, because what I was thinking is, instead of trying to repair this power supply or work out what's wrong with it, let's just join a power supply up to the board and see if this thing will turn on and do something. Look, there's a header there, or connector, that says PLD program. there must be a JTAG port for that, which looks like it's an Altera chip. It's got a little sticker over it with the software version, firmware version, I guess you'd call it. Like a CPLD probably. It's an Altera something. Maybe a Max 2? Oh, Altera Max, there you go. Well done. That Hitachi chip must be a display driver. Possibly. Or the Oki chip. Much Oki chips. I wonder if those are something good. 82C55A. That's just one of those port expander things, isn't it? Yeah, so I guess they've got memory mapped I/O, and those are expanding it out into various things. Anyway, we're looking at the power supply. Look how thin this is. It's very interesting. So it's Toco brand LW30-01, AC input 100 to 240 volts, wide range input. Doesn't switch probably, or does it using that? So we'll have a look at that. Outputs 5 volts, 3 amps, 12 volts, up to 1 amp, minus 12, up to 0.33. So it's pretty standard, but what's not standard about it is how thin this thing is. Look at those super low profile caps there, Elna brand. Presumably the output caps are ruined, that's normally what's happened in these things. You see there's a Mitsubishi control chip there. Mitsubishi control chip for it, so optocouplers for feedback. Guess that's like the voltage set. It'll be regulated on the 5V rail, and the other ones will just come along for the ride through the transformer regulation. Decent amount of output caps. There's a diode there, presumably a diode there, or maybe it's got regulated 12V outputs with 7879 series regulators, linear regulators. The current is low enough. Maybe, because that would be used for analog stuff generally. Now you see there the main switching FET in a sleeve, insulating sleeve there, pressed down to the bottom, and yeah, similar to how that diode is on a folded around piece. It's pretty interesting. And there'll be some snubber resistors. Catch the flyback. Let's take the power supply apart and have a little look at it. Have a look at the other side of the board, see if there's anything interesting going on. Doesn't seem to be any evidence of the capacitors leaking, but there often isn't, yet they're still dried out. Well, because they managed to just dry out very slowly without having to squeeze their insides out through the hole. There's another fuse there. It's interesting that they put another one on the outside. Not really sure why, because the one on the outside is still after the switch and input filter, so it's nothing additional there to be protected. Okay, let's see if this comes off easily. Should do it. The board is glued down to an insulating sleeve that's under it, which is interesting. Was there another screw? No. It's got little hooks at the bottom, at the back there, and the switching device is like stuck down from the insulating sleeve. Oh, and there's also double-sided tape holding this insulating plate down, which needs to peel off. Yeah, got all the good stuff on there. Yeah, so this is double insulated and it's fused on, so it must have been quite well stuck. It's interesting that they glued that down as well. So yeah, good double insulation. Pretty simple layout, although it's double-sided. That's what makes it look simple. I was wondering if that transistor looking thing was to do with switching line voltages, but I don't think so. The caps are just in parallel, so it won't have a voltage doubler on it. It's just a wide input range switcher. There's not enough power rating that doesn't need to have a voltage doubler in it for the 100 to 110 volt input range. It just changes its duty cycle. You can see the interesting layout technique there. The supply coming in off the rectifier there, made in Taiwan. So coming in off the rectifier there, feeds into the cap there, and then feeds into the cap there, and the current drawing out through the transformer FET back down through the other side. It's drawn off out of the terminal there and out of the terminal there. So they're properly controlling the current flow through the capacitors. Pretty good. See a similar technique here where off the diode into that pin, which I think, yeah, which is the top of the capacitor, then out of the capacitor and gap through there, control the current. Then again another presumably capacitor there. Then that. So they regulators. Let's see. I'll read what's on there. So it says 2412, and I don't know what the other one is. 79112 and 2412. Yeah, so they look like positive, negative 12 volt linear regulators. So it is what I suspected then. They're not using the transformers regulation. They are actual regulated 12 volt outputs. So presumably that one there will be the 5 volt output. Gruntier. Now we need to work out the pinning of this. Well, luckily they tell us right there. This is something. G1 ground 1, V1 the voltage 1 output, V3 ground 2, V2. So it's 2 output. The plus minus 12 will be those ones, and then that one there will be the plus 5, and then the other ground. In that case, you can see how this goes on here. Yeah, so it's listed in order of these. Oh, it actually says V1, 2, 3 on the label there that we've looked at before. For some reason not allowed to look at now. V1, 2, 3. So 2 is the outer edge one there, which has the red core, is the plus 12. Blue is the minus 12. Yellow is the plus 5, and brown, for whatever reason, is the ground, and black is the other ground. Should we just cut that, or wire onto it, or I saw there, oh yeah, look at that, plus 12, minus 12, it says there plus 12 EL, so maybe that's for the EL panel. Ground, oh I can't even see here, we get ground digital. Is there a 5 volt test point? Oh look, there's probably some business going on there. There's a battery, 2450 style battery. And plus 3 volts RTC. Ah look, plus 5 volts LED there. Guess there's all sorts of split rails. Maybe it'll just be easier to poke the pins out of this and wire onto them. Do we even, I was going to say, do we need to put the 12 volts on? It looks like it because it runs the EL panel. Okay, what we're going to do, get this little guy in to run the 5 volts. Then down here, tucked carefully out of the way and difficult to pull in, there is a power supply with dual outputs, so we can use that to make the plus and minus 12. We just have to get the thing out. Look at this. One of the good stuff where the cables is manually wired on the back of it. Awesome. Got a nice lambda power supply already with a nice link on there. So we should be able to dial that up to plus minus 12 volts and use that. Let's get that situated over here. Yeah, I might push the pins out of this plug and then pull the sleeve off, and then we'll be able to get good access to the connectors. So we'll dial up 5 volts on this thing. 5 volts, and I guess we'll just set it to 3 amps since that's what the original one would have been rated for, and that will be fine presumably. So we've got to push these out. Once we've tested this thing, we'll take these boards off and have a look at them. See what other goodies are lurking in here. Okay, so that's going to be our plus 12. Ground and our minus 12. And then we've got our plus 5. Another +5 for good measure. And our 2 grounds for the 5 volt. Good, that comes off fairly easy. So that's one setup. This is the other setup. So we'll just clamp these together in an alligator clip, nice and dodgy. That's awesome. And then the grounds, which is brown for some reason. Yeah, I'm just remembering it's the reverse of a computer setup where in the computer the 12 volts will be on the yellow and the 5 volts will be on the red, but they do it differently here, I guess. So the Sony way. Okay, and I'll get some leads out so we can do the other one. Some nice leads. So they used black as the ground, and then red and blue as a plus and minus. Just check that we've got the output voltages right before we hook that up. We're also going to turn off the power supply before we hook it up, and then we'll turn around the unit so we can see the front as it comes on or burns out or whatever it does. Okay, so black's the ground, and red should be +12. Well, that was a pretty good guess at setting up the power supply with the panel meters. And -12. Just make that slightly less. There you go, that's pretty much what we can hope for, isn't it? It's got to be exactly right. Good. It's going to change a bit when it gets loaded anyway. And I've put a somewhat generous current limit on there. Good, I guess. The positive one will need to be a bit more than the negative one. Okay, we'll switch that off. And now we're going to wire up these good guys. So the negative power supply is on the blue, positive's on the red, ground is on the black. Okay, we might be ready to juice this thing up. Just going to try and hope that none of that stuff touches itself. Don't want any touching. Now try and get this thing turned over. It'll be fine just leaning itself like that. What? Okay, so we'll just turn these on together and pretend that everything is going to be fine. Ready? Oh, look at that, it did stuff. Look at that. Whoa. So it draws 800 milliamps on the 5 volt and barely perceivable on the -12 and about 250 milliamps on the +12. So that's pretty nice. Pretty easy to go. Oh, look at that, and you can see the scanning. So these displays here are multiplexed. Guessing we can't do much because it's not hooked up to any control units. So I guess it won't let us actually do anything because it will need to talk to the cameras in order to do them. Do them? Oh. Maintenance. Adjusting. Phase. That's really nice, isn't it? Well, it is nice, but we can't do anything because I don't have one of the control units that it actually connects to. Shame we can't get these to do anything. Oh look, we can adjust the brightness of the EL display. We can adjust the brightness of the LEDs. Oh look, switch telly. Telly will be that one, but we can't show that unfortunately. Switches. Yeah, look, it's adjusting that. That's almost the only one we can get to come on. I wonder if that's like a power supply level. Other LEDs. Master. Ah, yeah, that's other LEDs, these little panel displays. Let's just crank all this stuff up to the max. Buzzer. Oh, look. There's levels for all sorts of things. Buzzers. Masters. Calls. Security. Engineer mode. You have to type in a code, do you? Code number is illegal. Ah, wonder what the code is. That's sad. Someone will tell us what the default code is. Oh well. The switch settings, shutter angle, date and time. Wow, it actually has the correct date and time. The time's not right. Date's correct. We can set it with these knobs. 23 or something. And the minute is 01 or 02. The second is just the second. Okay, so it's got a clock. That's nice. Okay, so I don't think we can really do anything with this because we don't have anything to connect it to. But it looks like it works. It's just the power supply was bung. Because it did not do anything when I plugged it in originally. Yeah, so it would detect what units are connected to it and let you control them. It would be reading data from them to tell you what it's currently set to. Great. Okay, let's turn it off. And we'll take it apart a little bit more to just see the stuff that's in it. Just get these bits and pieces out of the way. I'm going to have to get this connector out of the way so we can have a look at some of the boards. Oh, it's on a panel on the inside. I need to get that whole thing off. Oh, that's nice, that whole thing, whole assembly. Oh, I bent that ribbon cable quite badly. That whole AC power input thing comes out in one piece. Good. I wonder if this cable has to go around a certain way. Why does it say that on it? Could go around the other way? Strange. Strange. Weird that the power goes onto that, then takes this ribbon cable up to the main board where most of the power we used. So it's called, it's not called, so it says made in USA on that board there. Yeah, made in USA. Yeah, this board here says made in UK. Oh, there's things coming from all sorts of, it's like very multinational. Interesting little plug there for the display. Paint. I guess that's for, they call paint the display? I don't know. That button there was called paint. Oh, that goes to this bank of rotary encoders. Are they for painting, are they? Wow, gold-plated connectors. Pretty nice. Gold-plated. Okay, I think that's all the cables undone. Let's undo these screws and we'll take this nice board off and have a look underneath. I wonder how they do the brightness control. There must be some kind of good analog doofy somewhere that makes various power supplies. Oh, I bet it's those. There's three little transistor thingies. Probably got a PWM, an ETA, and then there'll be some little switching thingy to do that. Oh, look, they put some tape under the battery contacts so you don't accidentally short it out. That's a nice touch. Yeah, Sony made in UK. United Kingdom. I'm guessing that there is a display controller thing. Since there's the display connector. And then there's sorts of stuff and some what looks like more ROMs there. As well as the CPU with its RAMs and ROMs. And yeah, more of those I/O chips, some Sony branded chips. Look at that. The busing for banks of dip switches for setting various options. Diodes there, which I guess that's for doing the multiplexing. Now on this layer, it's got this card slot thing. Let's see where... So this board here says made in USA on it. Why would they get that one done in the UK? Do you think there's some kind of licensing thing going on? Seems a little bit weird. Card slot, made in USA. Sony. Yeah, it'll be one of those PCMCIA type flash memory cards. Now, in order to get this board out, need a nut driver on these posts. This might not want to come out because of the encoder shafts. Let's try it anyway. Since we're here, we might as well do it properly. This thing seems too nice to scrap, but I don't know what I'm supposed to do with it otherwise. Okay, so that won't come off because we've got to take these knobbies off. Not only that, we've got to take these knobbies off, and they'll need some kind of Allen key or hex type thingy. Let's find one of those that'll hopefully fit. There we go. Oh, the shafts have a flat on them. Oh no, that one's deeper. No, that's not fair. Oh no, it does fit. Yeah, these are scrunty. Look at that. That's solid brass. Wow, that's amazing. No wonder it feels so good to turn. That's a big chunk there. Wow, that's so deceptive picking that up. How heavy that thing is. No wonder it felt good to turn. It's a non-detinted type encoder. It's just smooth. With that nice heavy knob on it. Give it a good turn. Now that looks like an issue there. There's a return on that plate there. Were we supposed to do this a different way? Maybe this here comes out separately. I don't know if that helps though. Oh, there we go. Oh, look at that. Look at that, a nice LED matrix thing. I'm really sad we couldn't get that up and running. So it's on some kind of header thing with plugs and sockets. Some kind of plugged in header doofy. Oh, look at that. Yeah, what a nice thing. Okay, there's the beeper that was beeping at us. Pretty long shaft encoders there. They look pretty generic, but these ones here, Copal brand, nice units. There's another Hitachi something or other device there. Presumably these are LED switches, because we've got past light bulbs now, haven't we? So yeah, they've got LEDs in them. Otherwise half of them will be blown. And these are LED units. Interesting, that unplugs like that. Pretty nice unit. Now, there's a Sharp display, made in Japan. All the best stuff is made in Japan, so I'm told. And a beautiful transformer there, super low profile. So this thing won't have a backlight because it's EL, electroluminescent. It's probably got capacitors waiting to bite right now since we had it running. Okay, so the touch panel looks like it's fused over the glass, and then the display has got two cables. This one here, which will be all of the rows, come out to there, and then some kind of multiplexed thing here to that ribbon cable for the columns. But what's... oh, actually there's more rows on that side. And on that board there's drivers of some sort. I wonder if we can take that out. I wonder if that's wise without destroying this thing. Seems like it only has one screw holding it in. Oh, I see what's going on. It's like the... yeah, those don't actually go up to this board. They go onto the... like this other flat flex with the multiplexer chips. I was looking for that small flat screwdriver. Is gone now. Use that to launch that out. Then we should gotta flip that up. Yeah, look at that. Look at that. Wow. So the row driver ICs are on a flat flex. That's pretty insane. Insane? It's interesting, and we're probably stressing it a lot by peeling that ribbon cable up without unplugging it. Bizarre that it's only one screw holding that board on. That board's pretty heavy with these modules on it, optocouplers, like really flat transformers, some kind of thing in there. A pretty loose unit. And it's all in perfectly good working order apart from the power supply. Was in good working order. Anyway, I think we'll leave it there for today because we've made a good mess of that thing. Hopefully that was an enjoyable look at this. This was Sony Master Setup Unit MSU-700. Interesting piece of TV studio equipment for remote control of all of the cameras. Pretty nice deal. Come back next time and we'll take apart another interesting thing and take a look inside it.